Sometimes when we're solving a triangle, we have more than one missing angle. And this requires the use of trigonometric inverse functions in order to completely solve the triangle. Each of these functions has its own domain and range. Now, because sine, cosine, and tangent functions aren't inherently one-to-one, their inverse functions require a little bit of gymnastics to kind of get to work. But for our case, inside of right triangles, they work pretty nicely. And we can spend more time in a later section looking at them more in depth. So 3 of the inverse trig functions are given below: inverse sine, inverse cosine, and inverse tan. Let's remember or recall what we know about inverse functions. So for inverse functions, we know if I have some function where I have f of the input gives some output, then its inverse function, often denoted with a -1 exponent, we know that f inverse of that original output gives that input. And so it just switches the input and output. And so what I know about, say, sine is I have an angle value for an output and the ratio value. Angle value for input, ratio value for output. And for inverse sine, I am going to have the ratio value for the input. So here I have sine inverse of opposite over hypotenuse is then equal to, here's my ratio, which is on the inside now, and my angle is the output. So the whole point of these inverse trig functions is that the output is an angle. And this is going to help us do some kinds of solving where we need to find an angle value. Now, we have this as sine inverse here with little -1. You might also see this like in a calculator or in a textbook as arc sine, and they mean the same thing. So let's put it to work in an example where we're asked to solve a triangle. And we're going to go about this the same way. So they're giving me that A is 5 and B is 3, but asking me to solve the triangle. So that means they're saying, what's A, what's B, what's C in terms of side lengths, and what's A, what's B, and what's C in terms of angle values. So I'm already given some of those, so I like filling those in. That's easy. So A is 5, B is 3, and big C, that angle is 90 degrees. All right, what's left? Well, I need little side C and A and B angles. So because I'm in a right triangle, I can use Pythagorean theorem when it's convenient, and I think in this case I will use that for finding little c. So for little c, I'm going to say 5 squared plus 3 squared is c squared. That gives me 25 plus 9 is c squared. I have 34 equals c squared, and I have c equals the square root of 34. So c is the square root of 34, and I'm a third of the way done. Okay, great. So now I can find the measure of big angle A here or B. And it doesn't really matter where I start, so I guess I'll start with A. All right, so if I'm a little bug or a person, some living thing, standing at A, then 5 is going to be my opposite side, and 3 is going to be the adjacent. Of course, C will be the hypotenuse, but I really just need two side lengths here. And so I'm going to use just my regular sign, or let's see, what do I need? Opposite and adjacent. So if I write out my SOHCAHTOA, I don't want to skip that part. SOHCAHTOA. The tangent function relates my opposite and adjacent sides. So I'm going to say tan of A is opposite over adjacent, or 5 over 3. Okay, well that's good, except A is kind of trapped inside that tangent. And so what I just saw is that, when I'm in this right triangle, all's good. I have tan inverse of 5/3 is equal to A. And now I need a calculator. And I'm just going to label this as me doing A work. Okay, so tan inverse of 5/3. So if I go over to my calculator, and I just go down here, and I go to tan inverse. Well, I don't see that on here, so where can I find it? If I go to this FUNC menu, I see it right here. So I select tan inverse, and then I click back to main in order to enter what I want. And I want to enter 5 divided by 3. Once I do that, I can click this little right arrow over to just end the parenthesis, but This Desmos calculator kind of sees what I want already. So this is 59.04. And because I am solving for an angle, this is going to have degree. And again, I know that my calculator is in degrees because I'm just using it in degrees, but you always want to make sure before you start a new problem. 9.04 degrees. Okay, last one is B. So let's solve for our big angle B. Now I'm going to erase these adjacent and opposite marks here because now I am a little person standing at angle B, and when I look across, the side with a length of 3 is my opposite side, and the side next to me with a length of 5 is my adjacent side. But I'm still involving opposite and adjacent. Okay, so tan of B is opposite over adjacent, so that's 3 over 5. All right, B is trapped inside, so to make B the output, I need to switch my function to tan inverse. So tan inverse of 3 over 5 is B. Now that looks familiar, but it's not exactly the same, right? For A, it was tan inverse of 5 over 3, and this is 3 over 5. So I am doing a different calculation. So I get B is approximately, so tan inverse of 3 over 5. All right, so let's practice. Go over to the function menu, select tan inverse, go back to main, 3 divided by 5. I can use my arrow to get over to end the parenthesis around that fraction, and I get 30.96. So this is 30.96 degrees because I'm at an angle, and I can do this. And one thing that I do notice as kind of like a nice way to check, it's not totally foolproof, but I can look and see that my 3 angles add up to 180 degrees. And so it makes me feel pretty confident that I solved the triangle correctly.